I have been getting a lot of queries regarding finding out the unit vector using the path variable. Okay, so that concept we will try to clear it up through this example in this video. Okay, so what's given is say there is a path, maybe sorry, so there is a path in this coordinate system. Okay, and which is a helical path like that, given by say x is equal to a cos t. Okay, so t here, assume any parameter. It could be time, it could not be time also. If it is related just to a path, that it need not be time. Path in the sense a road. I'm saying if it is just representing a road, this t may not be actual physical time. Okay, if it is physical time, that means the particle actually is following this path. Okay, then say y is equal to, let's say, a sine t, and say z is equal to some constant c t. Okay, so that's given. And as we so this parameter now, if you represent say r vector, say any point here, fine. So this is the r vector. Say suppose this is x, this is y, and this is z axis. So r vector can be represented as say x of t I plus y of t j plus v of t k. So here I have assumed that the time is uh, t is time. Then r dot will give me velocity, r double dot um, will give me acceleration. Okay, anyways, so that's not the point. The point is we have said that unit vectors, say unit vector u of t and the normal vector, unit vector why I'm writing it, unit vector u and say normal vector p, unit tangent vector. Okay? So suppose at this location, say the tangent vector will be somewhat like that. So this is say u, and at that point say the normal vector, unit normal vector. So these are all unit vectors, unit tangent vector and unit normal vector. Suppose is p. So then how to find them? Because in any of the NT coordinate system problem, you will have to figure them out, and we have been denoting them as the En or epsilon n and epsilon. Sorry, that was not n, that was t, right? Epsilon t and epsilon n. So that's how we represent. Now, how to find them out in such condition? Mm, One in a previous example, we had seen that if from the picture it's easily you can draw the unit vector, and using the Cartesian coordinate system and the slope, generally it's possible in 2D, you can calculate them. Okay, if that's not possible easily, so what's the process to be followed? And we said that it's very easy if we can represent r in terms of the path variable, and then simply we can take the differentiation with respect to s. Okay, and some space here. Okay, so and in this one we can find out by say d of t over, I'll write epsilon t over ds, but here it will not be unit vector, and here it will come as 1 over r. Okay, so like that you can simply calculate the et and en. but the question what many students were asking, that how to write this as a function of Rs, because once you do that you can uh, carry out this differentiation very easily. Now let's see how to write this, which is now as a function of t, how to write that as a function of s, the path variable. So, so generally what you can do is, you know that the arc length you can calculate as r dotted with r, but we want in terms of time, say. So this you can say r dot with r dot. Okay, take a dot product of that and take the square root and dt. You integrate that from 0 to time. Fine. So basically this is what you will get. Uh, so this comes directly from the fact that dx square plus dy square plus dz square, so dx square is that. So yeah, so from there you can get this. Now but then what in this question, so let's try to evaluate. And so the idea is, you evaluate this, you will get a function of s as a function of time, then you invert that function to get t in terms of s and just substitute it here. So that's the basic idea. Now for this problem, what will you get? Say r dot, if you do say what will be r dot? R dot will be minus a sine t. Fine. So this x dot I plus a a cos tj plus c k, right? So that's your r dot, which has been calculated from this equation. Now you substitute it here. So what will you get? So square of this, so minus a sine t square plus a cos t square plus c square, right, under root dt, integral from 0 to t, right? So that you will get as a square plus c square under root dt from 0 to t, right? So that means this is equal to t over sorry t times t times a square plus c square. So this is what I was talking about, s as a function of time. Now if you invert this function to get t, you will get t is equal to s over a square plus c square under root. Fine. So that's what you can directly use there. So that's what I'm saying. So in place of t in this equation in here, you can simply substitute that. So what would you get? R is a function of s, maybe a cosine of s over a square plus c square under root I plus a sine of s over a square plus c square under root j cap plus c s over a square plus c square k cap. Fine. So this is now the function of s. then simply you can evaluate now epsilon t, suppose you want to evaluate. So simply dr over ds, it will come out to be what? Minus a over a square plus b square under root sine of s over a square plus c square, fine, plus a over a square plus c square under root cosine of s over a square plus c square plus c over k plus c over here I have under root plus c square under root, fine. So this I haven't written the ij case, yeah, so I then j and k, fine. So these are your et vector, and now if you want to write en vector, you just have to differentiate again this okay, so this one you just have to differentiate again. So we will write first, say d square r over d s square will be what? So a over a square plus c square cosine of so there should be a minus, isn't it? Cosine, okay, of s over a square plus c square under root minus a over a square plus c square sine of s over square plus c square under root, fine. So this is, again I'm forgetting, I and j, and this is a constant, it doesn't have any s term, so it's 0. So this is what this is not the en, but it's just d square r by ds square. But if you remember, did I write that somewhere? Yeah, so here, so so the modulus of basically that whatever you get is nothing but the radius of curvature, fine. So what you can do is so basically if I write r so I'll write d square r over ds, sorry, ds square, you just dot it with itself, okay, and take the square root. You will get the radius of curvature, fine. So that you can calculate, and it will come out to be a over a square plus c square, that's it, fine. So that means now your en vector in et, did I put the, yeah, I put that. En would come out to be this 1 over this, so I'll 1 over this times this, so these things will get cancelled out, and it will come out to be say minus cosine of s over a square plus c square minus, here again 1 over this will just cancel this, minus sine of s over a square plus c square. Okay. So okay, again I'm forgetting I cap j cap. So that's how you figure out E and et. So where was et? So here. So that's the general method using which you can figure out ET and EN in when you know. So basically, if the parameter used in the equation is time and not the path, then or T could be any other parameter, you can find this uh, unit vectors like this. So see you in the next video. Thank you.